Dear students, welcome to another day's lecture in Elements of Machine Design. Yesterday we saw about the keys, different types of keys, and also we consider different stresses that were coming in the sunk key, and how to design a sunk key, on what parameters it is designed we have seen. Okay, continuing with the keys. If anything, if anything is left, let us see here. See, keys are used to transmit torque from a rotating machine element to another rotating element, which is a shaft. You see here. Oh, see, keys are used to transmit from a rotating machine element to the shaft, or shaft to the rotating element. In this case, if the shaft is getting the power and you have to transmit to this gear, then the key is used. Otherwise, no. If this is not the drive shaft, if it is the driven shaft, then the power, the torque will be received by the gear and it should be transferred to this driven shaft. That also will be transmitted through this key, and the key will be sitting in keyway. Sometimes, no, here some set screw also is provided, so that if there is any gap or any clearance between this thing and that thing, that that set screws which are provided, because of the friction that they exert, they will set things in order. You see different types of keyways. All keyways are not same. See, these are the different types of milling cutters with which we are cutting the keyways, or key seat. Some people call it key seat also, in the shaft. You see, it can be from starting from the end also. Okay, you see, in case of woodruff key, it is a segment of a disc sort of thing. So you use a milling cutter like this, and rounded and closed. You see, you need such a cutter. Okay, and when you are drawing, you draw the keyways like this. Keyways, no, some standards are given where you can find out the keyways about those things in the standards. You see, tapered keys. The see, we studied about the tapers that are present in the keys. That is, taper is to the order of 1 in 100. See, the key is designed to be inserted from the end of the shaft after the hub is in position. You see, first take the pulley and assemble it in the shaft, and then you match the holes. Holes means what? The keyways. You match it, and afterwards you will insert the key. The taper will impart a compressive contact between the hub and shaft. Friction will help transmit torque and provide resistance to axial motion of the hub related to the shaft. You see, the axial motion resistance is provided. That means prevented. Axial motion between the hub and the shaft is prevented because of the taper. Okay, so tapered keys do not require set screws, but if it is parallel keys or feather keys which are parallel keys, then you may need set screw, because there may be some kind of gap there. Access to both ends of the tapered keys are required. See, both ends should be having access. Why? You see, once you want to insert, another time you have to drive out or take out the key. Inserting the key, you insert from one side, and removing the key, you remove from the other side with the help of some rod and hammer. Okay, like that. Here you see, this is a woodruff key. Sorry, this is a jib-headed key. See, jib-headed key. See, when you insert, see, this is a shaft which has an inbuilt collar, integral part. This collar is integral part with the shaft. When it is integral like this, say you inserted. So for inserting the key, you had access, but for removing from this side, no, you cannot remove. Why? Because there is a collar. At that time, no, Because it is having this head, you can put a wire around it and just pull it. If that is not there, how will you remove? So here in such cases, no ordinary sunk key will not do. Therefore, the jib head is needed. So here you see what we were saying is, for inserting also and for driving it out also, there should be access. Access means what? There should be place, for there should be an entry by which you can go and remove it. Okay. And here, the stress analysis of the keys, we have seen that, key has two failure mechanisms. It can fail in shear. That means, this is the shearing plane, along the entire length, the shearing plane. Okay. If this is W and the length is L, so W into L will be the shearing area. And also it can be crushed due to the compression bearing. Crushed means, you see, if the force is coming like this, okay, here, this half of it, that means T by 2. If the entire thing is T by 2 and length L, that will be the resisting area against crushing. Those are the two types of failure that we considered while designing the key. And there is stress concentration also, which we have to consider. See, cutting keyways creates a stress concentration in the shafts. These are there are different stress concentration factors for bending and torsional loads. So when we are designing, you see, earlier while designing shafts, how we considered KT and KM. Okay, like that. So here also, for flat, with the flat end mills, end milling cutters, you have cut it, then you have to use KT 2.14 for bending. So then this is not a T, it should be M. KM will be 2.14 and this will be KT is 2.62 for torsion. Okay, these may be these may be reduced by using key seats made with bull end mills. Is a bull end type of mills. If you are using, the stress concentration will be reduced. The stress concentration factor for a sled runner key seat is significantly lower than the profile key seat. Anyway, don't worry about all these strange names. Say, we are this is if you are further interested in knowing the keys and design of the keys at a higher level, maybe in B Tech, M Tech or something, then you can go for these, consider these things as if you are more interested, you want to make a project report of these keys and keyways and other things, then you can consider all those things. Okay, a circular key and keyway will have lower stress concentration factors than any other key geometry. Okay, but anyway, but you have to make a tight fit of the assembly, it seems. Okay. Okay, I think that's all we will discuss about the keys. You go through the textbook and if any other points we have missed, you can go through. You can see what are the commonly asked questions for keys, and you can accordingly prepare both theoretical questions and problems come from keys. Okay, but anyway, not many marks will be allotted. Maybe every time some 4 marks for the from the entire in one examination they may be asking. Okay, now let us come to the next topic, that is couplings. Couplings. Couple means two. Okay, couple means two. So couplings means it is something which joins two things. So couplings are used to connect two shafts for torque transmission in different applications. It may be to connect two units such as motor and a generator, or it may be to form a long line shaft. By, you see, line shaft means in one line there may be a number of shafts, so they are connected with the help of couplings. they are connected with the number of couplings and made one long shaft. Okay, why? Because standard shafts, standard lengths may be not more than 7 meters or something. I told you last time, because the truck length is normally some 7 meters or something. So the shafts are not longer than that. Okay, couplings may be rigid, or they may provide flexibility and compensate for the misalignment. When there is no misalignment, what couplings are used are called as rigid couplings, and where there is some misalignment and you have to compensate that misalignment, then what you use are called as flexible couplings. They may also reduce shock loading and vibration. So these couplings, they will be isolating the shocks and vibrations, provided you provide some damping elements inside. Okay, some packing material or some rubber and some such things. Okay, a wide variety of commercial shaft couplings are available, ranging from a simple keyed coupling to one which requires complex design procedure using gears or fluid drives, etc. However, there are two main types of couplings. They are rigid couplings and flexible couplings. So rigid couplings are used for shafts having no misalignment, while the flexible couplings can absorb some amount of misalignment on the shafts. Okay, in the next section we shall discuss different types of couplings and their uses, and under these two broad headings. Okay, before that I want you to see this video. Okay, okay, the functions of couplings are um, you know to to for connection, and for connecting the two shafts. For compensation, that means if any positioning error is there. Okay, for disconnection, if you want to disconnect motor from the machine now, and for damping purposes means if any vibrations and other things are there coming in the machine, that should not be transferred to the motor. Okay, for that. And compensation, this misalign the compensation means some misalignment. See, some things like, so now here two shafts are there, this is one shaft, this is another shaft, and there is some misalignment. This misalignment is a parallel misalignment. Okay, say otherwise you can say axial misalignment. Then the misalignment can be angular misalignment. That means what, this shaft's axis is in one line, and this axis is in another line, and there is some angular misalignment. Okay, even see, it is not it's a slight misalignments also. This couplings will correct. Okay, then this is the torsional misalignment. Suppose in one thing more vibrations are coming, in thing less vibrations, so they are known to for damping purposes and other things also. Okay, it can be used. 1 minute, yeah. And then there can be this one. 1 minute, yeah, this is running. Okay, I'll say there is an axial also. So if suppose there is some distance between these two, also that gap also, that it covers the coupling. Okay, and then see the couplings classification. If you see the couplings classification, it can be permanent and intermittent. Permanent, it can be permanent coupling. That means that's all, once you fix forever. Or it can be a thing that is temporary. Here they call it mobile. Okay, and couplings can be, in permanent there are two types, fixed and mobile. In that fixed mobile, no, rigid and flexible are there. And then uh, then in permanent in intermittent couplings, there is automated and this commanded. We need not know all these things. Okay, I'll stop here. You see, a rigid coupling is used to connect two shafts which are perfectly in alignment. That means the axes both are perfectly in one coaxial. uh, the coupling which connects two shafts will then be as though it is a single shaft. Okay, you see here there is a sleeve type. Actually, this is not sleeve coupling. This is a split muff coupling. You see, it is actually, it can be made of one piece, without a split like this. But if you split, see, you put the shaft here. There is a keyway, as you're seeing. There is a keyway here, and after the shafts are assembled, the keys are assembled, then with the help of this these bolts, you fix these two halves. This is a split muff coupling. And this is a flanged coupling. This type of couplings you may have seen many. Okay, this is a flanged coupling. See how many nut bolts are there? One, two, three, four. This here we are seeing it is not even 180 degrees. So another maybe some 10 nut bolts are there. It depends upon how much torque you have to transmit. So depending upon that, nut bolts will be there. Okay, and then the flexible coupling. Flexible couplings are used to transmit torque between two shafts when they have little angular or lateral misalignment. You see, this is a gear coupling. This is one type of flexible coupling. This is chain coupling. All these couplings we are not going to see at this level. This is some membrane coupling. See how you see, this is all for you. It is we will not be studying. Normally what we study simple things. Our education goes from understanding the simple and proceeding to the complex, simple to complex, simple to difficult. Okay, so first understand the simple principles, then the complex principles are only an extrapolation of the simple things, like that. Okay, so this is another coupling. See, actually, what type of couplings we are seeing are few couplings, but in real use, no, there are so many types of couplings. This is type of coupling is called as membrane coupling, and this is a grid type coupling. You see, it is a cut section is shown. See, this is a grid type. This also will not be seeing. Okay, and this is another coupling. This is a sleeve coupling. You see how the shafts are at some angle. These are all allowing some misalignments. That's why they are called flexible couplings. Okay, this is a pen drive coupling. See, you see the one side, it fits. These pins will be fitting inside the inside this flange. In this flange, it is a what wider diameter will be there. It will simply fit here. Okay, it is not. It will not. See, this is more like a bush pin type flexible coupling, which we'll be seeing here. We're seeing in our course. Okay, and this is a universal coupling or universal joint, which universal coupling will be. You can see under the truck. That propeller shaft will be having that universal coupling. And this is Oldham coupling. Here some spelling mistake. Oldham it is. You see there is a circular disc in the middle, and then on these two shafts, you see this axis of this shaft, this axis, they are not in perfect alignment. If the axes are parallel but not coaxial, then Oldham couplings can be used. Okay, like that. This you may have, this you may have Oldham coupling you may have drawn in machine drawing. Then this is, Schmidt coupling. There are so many types of couplings. This is jaw coupling. Okay, this also, yeah. You see, these are the jaws. In the gaps. This will be fitting. These things will be fitting. Okay, jaw coupling. And this is elastomeric coupling. You see, this is in the center some elastomer, like that. There are so many types of couplings. So but we will not be seeing everything. Okay, now let us see about the types and uses of shaft couplings under the heading rigid couplings. These couplings cannot absorb any misalignment. Cannot absorb means cannot correct or cannot be used for any misaligned shafts. To be connected by a rigid coupling must have good lateral and angular alignment. Okay, the types of misalignments are shown schematically. You see, if this is one shaft and this is another shaft and they are perfectly aligned shafts. Okay, suppose this is the axis of one shaft, this is the axis of another shaft. These shafts are with lateral misalignment. Laterally, there is some misalignment. If this is the axis of one shaft, if this is the axis of another shaft, then this can be called as shafts axes are with angular misalignment. This is a lateral misalignment and this is angular misalignment. Okay, so the simplest of all the couplings is a sleeve coupling. One of the simple types of rigid coupling is the sleeve coupling. Sleeve means what? You see, on the shirt you have sleeves. On the hand, you have either uh, half sleeve, full sleeve, or some sleeveless, some okay, sleeveless bunions and other things you may be wearing. Okay, these are sleeves. Sleeve means just something that goes on the cylindrical thing, shaft. Okay, this is sleeve coupling, which consists of cylindrical sleeve keyed to the shaft to be connected. So how you will connect this sleeved coupling to the shaft? With the help of keys. Keyed means keys provided. A typical sleeve is shown in figure. Let us see. Oh, 1 minute. Sorry. Where were we? No. Where is? Yeah. Here. See, this is one shaft, this is another shaft, and this is the sleeve. Okay, sleeve is just one hollow cylindrical piece. Okay, and these two shafts are brought together, and between the shaft and the sleeve you put a key. So thereby, what is happening? If this is the driver shaft, this is the driven shaft. So driver is rotating. So the torque will be transmitted from driver shaft to the key, and the key to the sleeve, and sleeve to the key, and again to the shaft. You see, this key can be one key, or this key can be two keys also. This half key separately, half key separately. Still, it will do the work. Okay, normal sunk keys are used in order to transmit the torque safely. It is important to design the sleeve and the key properly. The key design is usually based on shearing and bearing stresses. Bearing stress means crushing stress. You see, bearing stress is sometimes called as crushing stress. Bearing pressure is different. You should not confuse bearing stress and bearing pressure. Bearing stress is crushing stress and bearing pressure is bearing pressure. Okay. In some of the books they have confused. Okay, bearing stress is crushing stress. You remember, keep this in mind. If the torque transmitted is T, okay, now let us not say go for the design at this stage. Let us see only the types. You see here in this figure, what you see, this is the sleeve coupling. These may be some kind of set screws maybe also be used. Don't worry about these things. This is the sleeve coupling. Sleeve coupling also is called muff coupling. Muff coupling. Okay, this name is more famous in our polytechnic education. So sleeve coupling or muff coupling. And this is called as split muff coupling. split, it is split in the middle. So you see the sleeve coupling, what disadvantage is there? To insert this sleeve coupling between the two shafts, you need to have so much of gap, then only you can insert. If there's so much gap is not there, what you can do, you can use split muff coupling. So first, from the bottom you can put the half, and then the key also you can assemble it. Along with the key you can put this thing, and then put the top half, and then fasten it, tighten those nuts. Then you have flanged coupling. This is also rigid type coupling. It is a very widely used rigid coupling. It consists of two flanges keyed to the shafts and bolted. Okay, you see, this is the typical flanged coupling. See, flanged couplings look like this. This is the shaft, and this is the key. You can see this is the flange, and uh, and you can see the nut bolts here, and this is the hub. Okay, and actually this is, actually it is going like this inside, and this is some kind of protection it is provided. This is protected flange type of flanged coupling, whereas this coupling is the simple coupling. There is no this flange is straight. Okay, there is no such a recess like here. Okay, this is the simple flange coupling. This type is called as protected type flanged coupling. Okay, this flanged coupling in drawing, when we are drawing in the drawing sheet, you draw like this. You see, this is normally these flanges are made of cast iron. Okay, you see these two flanges are not identical flanges. You see, one has a kind of recess here. That recess will be circular. It will be circular. In this drawing it is looking like this, and in another projection will be there, one recess, another projection, so that they will exactly mate together. Okay, otherwise these holes will not be matching. The one will, what they will be, will have to struggle to bring them to alignment. Okay, so that's why the one has recess, one has projection, so there may be a little gap between them. Okay, see, otherwise if the gap is more, then throughout the gap will remain. Okay, then there are nut bolts here two nut bolts are there. There can be any number. You see, actually this is not the side view. You see, if it is a side view, it should have been so big circle. You see, from here to here, people put any kind of drawings. Okay, anyway, see here, this key, here one key is shown throughout it. Normally it won't be like this. It is no key from here to here, one key will be there, and this side key will be at an angle of 90 degrees. You see, this also one sometimes question they ask in interviews and other things, why these two keys are not in the same plane, why they are staggered at 90 degrees. Okay, like that they may ask you some question. Here this type of coupling is a protected type. You are seeing protected flange it is. Had it been straight like this, it will be an ordinary flange coupling. Okay. Okay, in next, flexible couplings. In these, as discussed earlier, flexible couplings can accommodate some kind of some misalignment and also some impact. They will isolate the shocks and vibrations. A large variety of flexible couplings are available commercially. The principal features of only a few will be discussed here. Old ham coupling. This old ham coupling it accommodates both lateral and angular misalignment to some extent. No, I don't think it is a angular misalignment. Lateral misalignment it can accommodate, if the axes are not coaxial but they are parallel, then you can use. Oldham coupling consists of two flanges with slots on the faces, and the flanges are keyed to screw. The faces are keyed or screwed to the shaft. A cylindrical piece called disc has a narrow rectangular raised portion running across each face, but at right angles to each other. The disc is placed between the flanges such that the raised portions fit into the slots in the flanges. The disc may be made of flexible materials, and this absorbs some misalignment. A schematic is shown in the figure. It is like this, this about this you have seen, you have drawn these things in the machine drawing, so you may be knowing. This is the circular disc. See, it has a projection here, and on the other side 90-degree going like this. Okay, and this that fits here, and this fits in this one, and then it is keys are provided. Okay, and to connect this shaft and this flange. Similarly, this shaft and this flange, another key will be provided. Okay, here you can see the Oldham coupling in a video. See that circle central disc is made of material, and this is how made of a material which will absorb and some misalignment and provide some flexibility. You see, this is how it is. See, from the other side it is seen like this. Okay, when it is running at full speed it will be seen like this. Okay, when it is broken, I think. So this is how a Oldham coupling looks. Then universal joint. This universal joint, these joints, universal joints also can be called as universal couplings. These joints are capable of handling relatively large angular misalignment, and they are widely used in agriculture machinery, machine tools, and automobiles. Okay, a figure is shown. There are many forms of these couplings available commercially, but they essentially consist of two forks keyed or screwed to the shaft. There is a central piece through which pass two pins with mutually perpendicular axes, and they connect the two fork ends such that the large angular misalignment can be accommodated. This coupling, often known as Hooke's coupling, has no torsional rigidity, nor can it accommodate any parallel offset. Parallel offsets, see, it won't. See, this is a typical universal joint. You see, universal joint, if you see in the this thing, normally how you draw a universal coupling may look like this. Are you seeing this? You have drawn in machine design, and these are the different parts of it. There is a fork, see, shaft, key, fork, and then this is the center block. Center block has, two cylindrical pieces welded together or made integral part. Okay, and then this pin goes through, through this cylinder. This pin goes through this cylinder. On the other side there is a collar, and in the collar, locking this collar and the on this pin is the taper pin, and the other side also similar like this. This is the universal coupling. Then you have, pin type flexible coupling, normally which we call as bush pin type flexible coupling. One of the most commonly used flexible couplings is a bush pin type flexible coupling, flexible flanged coupling, in which torque is transmitted from one flange to the other through a flexible bush but around the bolt, put around the bolt. This is shown in the figure. These are used when excessive misalignment is not expected, such as a coupling between a motor and a generator or a pump mounted on a common base. Okay, let us see. Hey, where is the figure? Bush pin type flexible coupling. Okay, here the figure is not missing. I'll show you somewhere else. Yeah, here you can see. You see, this is a flange. This is the hub of the flange. Shaft will be this side, and shaft will be this side. This is another flange. In this, a wider, of larger diameter holes will be there. This will be pin will be fitting. Okay, see here, this is the normal drawing which we draw on the drawing sheets. This is a what half section. It is shown, that means below the center line we are showing as though it is not cut, above the center line as though it is cut, and inside parts are seen. This is half section. Okay, so from the outside if you look, you will see like this, but when the inside if you cut, no, you will see the shaft extending up to this portion. You see key of this side is here, and the key of the other side is at a 90-degree, on a plane um, of 90 degrees. Okay, and then this, you see here, this side, this side, it is firmly fit here into this hole with nut and everything. Then this is called, this is not bolt, this is called pin. This is a circular, you see, it is not a hexagonal. Are you seeing here? This is a circular head will be there. This is called pin. The pin's head. This is the pin. This is a large portion of the pin. This is it has threads at the end, and it will be screwed here. It should be screwed here into this flange. Okay, and above this pin you have two bushes. One is a brass bush, another rubber bush. You see inside, it's a rubber bush is seen below this. Brass bush should be there. This permits a misalignment of maybe some 2 degrees or something. Okay, here you can see this figure here. How this is. This is exploded view of the bush pins. Okay, this is how it is. Okay, today we'll stop here, and tomorrow we will see the design of the couplings and other things. And today's quiz will be completely on keys only. Keys continued. Okay, we'll stop here. Thank you.